Hello and welcome to E233. I'm your instructor, Gregory Myers. In this video, we're going to take another look at while loops. This video is part of a larger series of videos focusing on the fundamentals demo and the fundamentals of the C programming language. This video assumes that you've watched some of the earlier videos on loops, and while it is not necessary, it is helpful that you will have completed the for loops _03 video. And the idea being is that we're going to essentially take a look at how you would do the exact same example using a while loop. And so to begin with, you want to go ahead and grab a copy of our while loops _03 snips file. And you'll notice it's just got the prototype in it, as well as a function stub with a nice little table that I've started. Now, let's go ahead and jump down into the list of prototypes. Let's go ahead and copy over our new function prototype, and we'll put it with our other while loops. And you'll notice that this one, unlike the earlier ones, accepts three arguments: the start, the increment, and the end. And for simplicity's sake, we're just leaving these all as integers. As you'll discover later on, is there's no requirement that a while loop uses only integers. But go ahead and copy then the function stub down to the code. Let's go ahead and see if we could take a second to find our other while loops, and we'll simply put them all together. Now, going back up to our main for just a second, what we want to do is we want to go ahead and look at our for loops _03 to sort of get a guide for how we're going to collect the information from the user. Now, we could do this parametrically, or we could do this interactively. It doesn't really matter. But I just like to keep this example in parallel or in tandem with what we've already seen. So what I'd like to do now is I'd simply like to add another condition using an else if and our string compare I. RV square brackets 1. And at this point, basically, if the user wants to run our while loops _03, well, then what we need to do is we somehow need to collect three pieces of information. And so we now need to collect the start, the increment, in the end. Now, hopefully you've experienced enough with the command line to know that we could also collect this information as additional arguments, and then we could potentially use the A to I function that would allow for us to convert those strings into the additional arguments that we need for our function. We can play around with this perhaps in a later video. For right now, let's go ahead and just follow what was done earlier. And that is, we simply want to have pairs of printfs and scanfs that collect the start, the increment, and the end. So functionally or fundamentally, from this perspective, it won't be any different. Just like in the for loops example, we are going to do no validation or no error checking outside the function. We're going to assume that the user did in fact enter in integers, that they were handled correctly by the scanf. We're not even worried about whether the start and the end are in the correct order with respect to the increment. We're going to handle all that inside of our function. And as a result here, then when we call our function, we want to get some sort of useful feedback back from it. And so we're going to say results are going to be equal to while loops _03. And we're going to pass it the start, the increment, and the end. Now, once again, it probably would be a good idea for us to do some sort of validation, but for this example, we're going to assume that we're going to handle all the validation inside the function. And at this point, we simply want to say, congratulations, your loop ran %d times, and we'll just capture that using that results variable. At this point, everything is wired up and ready to go. So let's go ahead and jump down to our while loops underscore 03 function. And let's get to work making it behave like the for loops version 3 did. And so in order to do that, we want to go ahead and capture or track not only the count, in other words, how many times our loop runs. And as a matter of fact, what we want to do is we want to go and initialize it to 0, but we also want to go ahead and return that count. The other thing that we're going to need is we're going to need some variable to capture the current value of the loop. Now, when we were doing for loops, it made sense to have an index variable. I'd like to tweak that ever so slightly. Fundamentally, they behave the same, but I'd like to call this one current. In other words, I want to know what the current value is in the while loop. At this point, then, what we want to do is we want to handle some logic inside of our function. And particularly what we want to do is we want to look at a couple of different scenarios. The first one is when the increment was less than 0. In other words, basically the user of your application wanted your while loop to count down. The other possibility, of course, is then that the increment was greater than 0, which means that they wanted it to count up. And then the only other possibility that would be left here would be that our increment was equal to 0. And you can sort of see how we are essentially pairing off possibilities here and dealing with them separately. And so I'm going to make a quick note here. The intention here was to count down. The intention here was to count up. And this right here has some ramifications. If the increment is in fact equal to 0, this means that it's never going to change. And that's not good, because effectively what that means is the user has inadvertently tried to trick us into running an infinite loop. And so what you want to do here is you simply want to provide some sort of message back to the user that says warning, perhaps not necessarily an error, but it says that our increment must be non-zero. So the same behavior that you would have gotten with a for loop, you're going to get with a while loop. And simply put a message here that says, or you will get an infinite loop. Now, the way we have our logic structured, it is quite possible that we have other issues. In other words, that the start and end might be wrong, but at the very least, let's check the increment first. This kind of makes our logic a little simpler. Now, let's think back to the scenario where we're counting down. Well, counting down simply means that the end must be greater than the start. In other words, excuse me, let me reverse that. If we're going to count down, that means that our start must be greater than our end. In other words, if we want to count down from 10 to 0, 10 must be greater than 0. If we want to count up, then this simply means that our start must in fact be less than our end. And so what we can do now is we can handle this with a flat if structure, but a nested structure sort of helps us, or sort of makes it make a little more sense, in that what we can do now is we can simply just take our comments and we can put them into code. And so that if our end is in fact greater than our start, we simply provide, once again, a warning to the user, maybe not necessarily an error, but a warning. The increment is negative and the end is greater than the start. In other words, rethink what you're trying to do. And under the else, we can actually go ahead and write some usable code. So here is where our code goes. Now, before we lose our train of thought on this, let's go ahead and handle this branch as well. So in other words, if our increment is greater than 0, that means our start must be less than our end, in which case what we can do is we can simply just reword this a little bit and say that if, in fact, our end is less than our start, we can, once again, provide a print statement to the user with a warning that says our increment is positive and the end is less than the start. And I just want to take a second to point out that this is not really an error, because fundamentally what happens in both of these warning conditions is that our loop will simply run 0 times. So you could argue that effectively it's not a bug, it's behaving the way it's supposed to. It's not a bug, it's not the application hasn't been used incorrectly by our user, hence the reason that it's not really an error. Now, as I said earlier, here is where our code goes. Now, in the for loop example, we simply constructed all of this inside of the for loop using the initial conditions, the final conditions, and then the increment. And so as a slight tweak, we have to do the same with a while loop, but we have to initialize some of the values outside of the while loop. And specifically, we've already initialized our count that will simply keep track of how many times our while loop runs, which we defaulted to 0. But we also need to keep track of our current value inside the loop. Now, if we are dealing with an increment less than 0, effectively what we want to do is we want to start off at the higher value here. And so what we want to do is we want to think about then where does the current variable start? And well, that's just quite frankly assign whatever was put in by the user for the start. Now, our while loop can simply run while our current is going to be either less than or greater than, or less than or equal to, or greater than or equal to whatever the end value is. Now, to determine what sign this needs to be, we want to think about whether we're counting down or whether we are counting up. And as we said in this particular case, we're counting down. Why do we say that? Well, because our increment was in fact less than 0. So that tells us that we want our while loop to continue to run while the current value is greater than or equal to our end value. And as soon as it slips below that end value, we want it to stop. At this point, then what we want to do is we simply want to print out what the current value is. So let's take a second to construct a table around this while loop. We'll use a familiar pattern here. We'll have our index, or how about if we say the current value. And what we're going to do is we're just going to do something silly here. We're going to make some sort of change to that current value. In this case, what we're going to do is we're just going to multiply it by 2, nothing complicated, just so that you can see how we can leverage a while loop, much like we leveraged our for loop. And then inside of here, we're going to do nothing more than print using %d, and a little further, another %d followed by a new line, and we're going to specify whatever the current value is, and then once again we're simply going to multiply the current value by 2. You can optionally consider putting parentheses around this as well. And at this point, we're essentially done with this branch, except for the fact that we have not changed our current value. In other words, every time this loop runs, we want to change the current value. If we fail to change the current value, what we wind up with is an infinite loop, because the condition never changes. In other words, this will always be true, and the loop will continue to run, in which case, if you run this from the command line, you'll want to hit Control-C. But to prevent this, we can simply say current now is equal to current. And once again, we can decide how we want to go about handling this. In this particular case, we're assuming that the user is entering a positive value for the increment, even though they intended to count down, or we can assume that since the increment is negative, then that they could specify whether it was a negative or positive when they were entering it in. Once again, it's just how we word it. In this particular case, we allow for them to enter in negative values. And so we simply do current is equal to current plus increment. And that seems a little strange, but remember that the increment can technically be negative. And so effectively at this point, we are counting down. And so take a second to make sure you really appreciate what's going on here before you continue then to the next part. Now, a little correction in my comments there. Let's move on to the second block of code where we do roughly the same thing. And so we start off with current is equal to start. As a matter of fact, what we'll do is we'll go ahead and borrow our print statements just so that we have a consistent looking table here between the two branches of our if statement. And then we want to construct our while loop. And this is where the difference lies. And so in this branch right here, we want to take a look at the current value, but then we want to stop it once it reaches the end. But the difference is that the current value should be less than or equal to the end because our increment is positive and our end comes after our start. And so essentially the only difference between these two branches is simply the sign. At this point, then we can go ahead and borrow our print statement from earlier, making the rather trivial modification to whatever the value of current is by multiplying by 2, just to demonstrate that we can. And then once again, we want to think about the incrementing of our current. And so we would say increment or current is equal to current plus our increment. And once again, since the sign is handled in the increment itself, we don't change the sign in the computation. Now, a little bit of changes here. I seem to have a typo once again in my comments, nothing major. However, though, we still need to do one more thing in both of our branches of our if statement. Remember, the point was to keep track of how many times our loops ran, so that every time we change the current variable, we simply come along and we increment our count. And so in both branches, we simply say count is equal to whatever the current value for count is plus 1. Now, probably at this point, you've seen some of the shorthand notation. I'd like for us to be familiar with the longhand notation because it's more universal among different languages. Although if you are really comfortable using, for instance, in this case, count plus plus, feel free to do so, or even count plus equals 1. Either is perfectly fine. But at this point, essentially, our while loops 03 is effectively done because we have returned the count. And at this point, you can simply then get rid of these notes here. The idea is I was going to borrow from this table here. And quite frankly, in this video, I completely forgot about it. So if we go ahead and build it, we should have a successful build if we haven't made any typos, at which point you can come over here to your command line. And what we can do is we can run our fundamentals demo.exe, this time with our while loops underscore 03, enter a starting integer. How about if we put in 0, we enter a increment integer of 1 and an ending integer of 10. And you can see here that I'm going from 0 to 10, not only with the current value or the current, and then times 2 times the current And a little bit of tweaking on our tabbing to make our table look good, modifying the format spec with a little bit of padding. But once again, that is the goal for this video, so much as to see that we're working correctly. So let's try to break this. And so we'll start first, let's do the reverse. So we'll start at 10. We will specify -1 for the increment and our ending 0. That seems to work correctly. Now what we're going to do is we're going to do it wrong, starting with 10, an increment of 1, and a ending of 0. And it's saying increment is positive and the end is less than the start. And you'll also notice that in every one of these scenarios here, it was also telling us how many times the loop ran. In this case, it says, congratulations, your loop ran 0 times. You can argue that's perhaps a little bit sarcastic, but it hopefully makes sense to you what's going on. We can do the same thing now with a negative increment. And once again, increment is negative and the end is greater than the start, and hence the loop will run 0 times. So hopefully, if you've compared this with your for loops example, this makes sense to you. There is no requirement that you use integer data types for this. You can actually use any of the numeric data types, as well as you could see there's some other tricks that you can use with while loops, namely even characters. But fundamentally, though, this demonstrates how you would do the exact same thing with a while loop that we had earlier done with a for loop. So as always, if you have any questions, comments, or concerns, don't hesitate to contact me. And thank you for watching.